Hello students, myself Henasha, Assistant Professor at LG Institutes of Engineering and Technology. Today we are going to discuss few more topics of partial derivatives. So let us begin with its first topic, that is chain rule. If z is a function of u, where u is a function of g of x comma y. Now let us make a tree diagram of this. That is, see, this is z is a function of u and u is a function of x and y. So here we will put d, and in these two things we will put del because it is a function of two variables. Now if we need to find del z by del x, then the formula of del z by del x will be dz by du into del u by del x, dz by du into del u by del x. Similarly, if we want to find del z by del y, then the formula of del z by del y will be equal to dz by du into del u by del y. Right? Next, let us discuss the next topic, that is total derivative. If u is a function of x and y, where x is a function of t and y is also a function of t. So now let us make the tree diagram of this. So u is a function of x and y, and x and y are function of t. So here we have two variables. So what we will put? We will put del in the first part. And now x and y are function of t only, that is one variable. So what we will put? D in both the parts. We need to find the partial derivative, that is total derivative of u with respect to t. So what we will put over here? D. So finally the formula of du by dt will be equal to, first go with this side, del u by del x into dx by dt. Now move on to this side. So plus del u by del y into dy by dt. Now let's see one more formula of total derivative for three variables. So again, if u is a function of three variables x, y and z, where x is a function of t, y is a function of t and z is also a function of t. So firstly, let us make the tree diagram. Here also u is a function of x, y and z, that is three variables, and x, y and z are function of one variable t. So in the upper portion what we will put? Del everywhere, and in the lower part we will put d. Now if we want to find the total derivative of u with respect to t, then the formula will be du by dt. Firstly it will be del u by del x into dx by dt, plus now the middle part, del u by del y into dy by dt, and lastly del u by del z into dz by dt. So this is the formula of total derivative for three variables. Now let's solve one example. Here we are given if w is equal to xy plus z. So w is a function of three variables and x is equal to cos t, y is equal to sin t and z is equal to t. We have to find dw by dt. So firstly let us make the tree diagram. W is a function of x, y and z, and x, y, z are function of t. So here we need to put del, and here what will come? D. So finally make the formula of dw by dt, which will be equal to del w by del x into dx by dt. Right, first part. Now move on to the middle part. So plus del w by del y into dy by dt plus del w by del z into dz by dt. So this is our formula. Now we have to solve all the six parts. So firstly let us find del w by del x. That is, we have to find partial derivative of this with respect to x. So what we will keep constant? Y and z will remain constant, right? So the only answer will be Why? Because the derivative of x will be 1 and the derivative of z, which is constant, will be equal to 0. Now find the dx by dt. Now our x, that is equal to cos t. So derivative of that will be equal to minus sin t. Next, plus, now find del w by del y. So here what will remain constant? X and z will remain constant. So find the derivative. So only x will come, right? Because the derivative of y will be equal to 1 and this is constant, so it will be equal to 0. Now find the derivative of y with respect to t. Now y is sin t. So the derivative will be equal to cos t. Plus, you have to find del w by del z. So in this, we have to keep x and y constant. So the derivative of this will be equal to 0. Only the answer will come as 1. And finally find dz by dt. Now our z is t. So the derivative will be equal to 1. Right? Now finally, in order to find the final answer, you have to replace the values of y and x. We know y is equal to sin t, which is given in question. So replace by that. So this will be equal to minus sin square t plus, now x is equal to cos t. So this will be equal to cos square t plus 1. Now we know cos square t minus sin square t, that is equal to cos 2t plus 1. So this is your final answer of what? dw by dt. Now let's go to our next example. Here, if z is equal to xy square plus x square y and x is equal to at square, y is equal to 2at, then we have to find the value of dz by dt, right? So let us move on to the solution. Here you can see that z is a function of x and y and x and y are function of t. So in the upper part you have to put what? Del, and in the lower portion what will come? D, right? And you have to find total derivative dz by dt. So now let us make the formula of this. So dz by dt will be equal to del z by del x into dx by dt, right? Next, del z by del y into dy by dt. Now we have to find the derivative. So let us find del z by del x. So in order to find this, you have to keep what constant? Y as constant. So keeping y as constant, so answer will be y square plus 2xy. Now find the derivative of x with respect to t. Now your x is at square, so answer will be 2at. And now find the partial derivative of z with respect to y. So here you have to keep now what constant? X as constant, right? So keeping x constant, the answer will be 2xy plus x square. And the derivative of y with respect to t will be equal to 2a. Now finally put the answers of x and y, that is at square and 2at, in the following equation and simplify. So finally you will get the answer of dz by dt as 16a cube t cube plus 10a cube t raised to 4, right? So now let's go to our next example. What is the next example? For z is equal to tan inverse x by y, where x is equal to u cos v, y is equal to u sin v. You have to find del z by del u and del z by del v at point 1.3, 5 by 6, right? So now let us go to its solution. So here z is a function of x and y, and x and y are function of u and v. So all the things are in two variables. So everywhere we will put del. Now firstly ignore this v and find del z by del u. So del z by del u will be equal to del z by del x into del x by del u plus del z by del y into del y by del u. Now put the values of the derivatives. So firstly we will find del z by del x. We all know the derivative of tan inverse x will be equal to 1 upon 1 plus x square, right? So here the derivative of tan inverse x by y will be equal to 1 upon 1 plus x square upon y square. And here we are keeping what constant? Y as constant. So finally applying chain rule, what will we have? 1 upon y. And derivative of x with respect to u, that is the derivative of this with respect to u will be equal to cos v. Again del z by del y. So here you have to keep x as constant. So derivative will be 1 upon x square plus y square, and derivative of this with respect to y will be equal to minus x upon y square, and del y by del u. Here del y by del u will be equal to sin v. Now finally simplify and put in place of x u cos v and place of y u sin v. So on simplifying you will get answer of del z by del u as what? 0. So now let us find del z by del v. Again now ignore v and write the formula. So del z by del v will be equal to del z by del x into del x by del v plus del z by del y into del y by del v. Now we have the values of z, which is equal to tan inverse x by y, and x is equal to what? U cos v, and y is equal to what? U sin v. Okay. So now find the derivatives again with respect to v. So firstly del z by del x will be equal to say 1 upon x square plus y square into 1 upon y. Only change will come over here. So the derivative of cos v with respect to v will be minus u sin v plus this will again remain same, and find the derivative of y with respect to v. So it will be equal to u cos v. Now again put the values of x and y which are given, u cos v and u sin v, and simplify. So you will get the answer of del z by del v as minus 1, right? So now let us solve one more example again, which is very important. Here we are given if u is equal to f of x minus y, y minus z, z minus x, then we have to prove that del u by del x plus del u by del y plus del u by del z is equal to 0. Now let us begin with its solution. So here we have to assume that x minus y is equal to L, y minus z is equal to m, and z minus x is equal to n. So finally u is a function of what? L, m, n. So now let us draw the tree diagram. So u is a function of L, m, n, and L, m, n are function of what? X, y, z. So in all we have more than one variable. So everywhere what we have to put del. So firstly we will begin to find del u by del x. So del u by del x will be equal to del u by del l into del l by del x plus del u by del m into del m by del x plus del u by del n into del n by del x. Now what is our L? L is x minus y, m is y minus z, and n is z minus x, right? So we have to find del L by del x, del m by del x, and del n by del x. So let us find. So del u by del x will be equal to, this will remain as it is, del u by del l. And we have to find the derivative of this with respect to x. So y will be constant. So derivative will be equal to 1. Now again find the derivative with respect to x of m. Again we have y and z as constant, so answer will be equal to 0. And lastly find the derivative of n with respect to x. So the derivative will be equal to minus 1 because z is constant. Simplify. So again del u by del x will be equal to del u by del l minus del u by del l. Now let us find similarly del u by del y. Formula of del u by del y is equal to del u by del l into del l by del y plus del u by del m into del m by del y. plus del u by del n into del n by del y. So now let us find the derivatives of these three terms. So it will be equal to minus 1, 1 and 0. Now we have to keep which terms constant? X and z constant in order to find the derivatives of these three things. Similarly, find del u by del z. So del u by del z will be equal to del u by del l into del l by del z and so on. So find del u by del z by keeping which terms constant? X and y constant. So final answer of del u by del z will be equal to minus del u by del m plus del u by del n. Now add 1, 2 and 3. So adding 1, 2 and 3 we will get our desired answer, that is del u by del x plus del u by del y plus del u by del z is equal to 0. Now let us go to our next topic, that is implicit function. So first let us define what is an implicit function. Any function of the type f of x comma y is equal to c, where y is a function of x and c is constant, is called an implicit function. So for example, x cube plus y cube is equal to 3xy is known as implicit function. So now let us solve the formula for implicit function. So if f of x comma y is equal to c, where y is a function of x and c is constant, then dy by dx is equal to minus del f by del x upon del f by del y, that is equal to minus fx upon fy. This is known as implicit differentiation. So let us prove this formula. So if f of x comma y is equal to c, then the total differential coefficient of f with respect to x is given by df by dx is equal to 0. So we will find df by dx. So that will be equal to del f by del x into dx by dx plus del f by del y into dy by dx is equal to 0. Now what we will do is we will make the formula of dy by dx. So dy by dx is equal to finally minus del f by del x upon del f by del y. So this is equal to minus fx upon fy. So finally we have proved the formula of implicit differentiation. So now let's solve one example of implicit differentiation. So if x cube plus y cube is equal to 3axy, we have to find dy by dx. Now we know the formula of dy by dx, which is equal to minus fx upon fy. So firstly let us begin with its solution. So here the function is x cube plus y cube. Take this on this side. So minus 3axy. So firstly we will find fx. So fx is equal to del f by del x. So we have to find the derivative of f with respect to x. So we have to keep y as constant. So the answer will be 3x square minus 3ay. Similarly find fy. So we have to keep x as constant. So answer will be 3y square minus 3ax. So finally our dy by dx will be equal to minus del f by del x upon del f by del y. Put these two answers over here and now take out 3 common. So final answer of dy by dx will be equal to minus x square minus ay upon y square minus ax. Right? And take this minus inside. So finally the answer will be ay minus x square upon y square minus ax. Let's solve one more example. If cos x raised to y is equal to sin y raised to x, then we have to again find dy by dx. So let us begin with the solution. So here we are given cos x raised to y is equal to sin y raised to x. So firstly we will take log on both the sides to make our differentiation easy. So taking log we will get y log cos x is equal to x log sin y. Here we have used the formula of log a raised to b, that is equal to b log a, right? So now our function f of x comma y will be equal to y log cos x minus x log sin y. Now let us find fx. So fx will be equal to, here we have to keep which term constant? Y as constant. So it will be equal to y into, derivative of this will be 1 upon cos x, and using chain rule, derivative of cos x will be minus sin x. Now again log sin y is constant and derivative of x will be equal to 1. So finally the answer of fx will be equal to minus y sin upon cos, that will be equal to 10x minus log sin y. Similarly, we will find fy. So here we will put x as constant, right? So here derivative of this will be equal to log cos x into derivative of y will be equal to 1 minus x will remain as it is, and derivative of this will be 1 upon sin y, and applying chain rule, derivative of sin y will be equal to cos y. Finally, the answer of fy will be equal to log cos x minus x cot y. So our dy by dx will be equal to minus del f by del x upon del f by del y. So put the answer of del f by del x and del f by del y and take this minus sign inside. So the answer of dy by dx will be equal to y tan x plus log sin y upon log cos x minus x cot y, right? So in today's lecture we have studied firstly chain rule. So in this, if z is a function of u and u is a function of x and y, then the answer of del z by del x will be equal to, here we have to put d and here we will put del, will be equal to dz by du into del u by del x. Similarly, del z by del y will be equal to dz by du into del u by del y. Next we had studied total derivative. So if z is a function of x and y and x and y are function of t, and we need to find dz by dt. Firstly here we will put del, here we will put d, right? And if you want to find dz by dt, then the answer will be del z by del x into dx by dt plus del z by del y into dy by dt. Similarly, you can find the formula for three variables. And next we have studied what? That is implicit differentiation. Implicit differentiation. The formula for that is dy by dx is equal to minus fx upon fy. So I hope you have understood throughout the lecture. Thank you for watching.